Hi everyone, welcome to this new lecture of fluid mechanics. In this lecture we will discuss the topic about the rate of flow or discharge, and after that we will discuss about the continuity equation. So this rate of flow or discharge is nothing but we can define this rate of flow or discharge like the quantity of a fluid which is flowing per second. We can say the quantity of fluid which is flowing per second, okay, per second we can say, or we can define like it is defined as the quantity of a fluid which is flowing per second through a pipe or a channel. So this is supposed to be flows along with a pipe. Suppose this is the pipe is there, okay, and in this the liquids or fluids which is flowing. So we need to see what is the quantities here means in the pipe you consider. Then we need to talk about the volume of the fluid, okay. So this is known as the rate of flow or discharge, and this rate of flow or discharge is denoted by a capital Q. This is the definition and this is the notation or indication of this rate of flow or discharge. So these things will be different for the different kind of fluids, because the fluid we have seen previously, it can be also like categorized by the fluid. If you see, it can be one will be liquid will be there, another one gases. This one already I told the starting of the lecture. So this liquid you can consider any kind of this may be compressible or incompressible, but here if liquid is there means that will be incompressible, and while you can consider the gas, it will be compressible one, okay. So for both the things it will be different. Yeah, for liquid if you see, then we need to indicate like what is the liter per second or what is the fluid is flowing per second. So that one we can write, this one we can write, this one, okay, so this one, let erase this. Yeah, we can write this in terms of liter per second. This one we can write liter per second. That means what is the quantity of fluid which is flowing per unit second. This one we can write liter per second, or we can write volume per second. So volume per second is nothing but we can write meter cube per second. So this incompressible liquid we can define in terms of liter per second, or we can say in meter cube per second, that is nothing but a volume per second. And for gaseous case it will be different. That is the weight of the fluid per second, weight of the fluid, okay. So that one we can write in terms of kg force per second, or we can say this is Newton per second. Both can be defined in this way, okay. For this incompressible fluid, the rate of flow or discharge can be expressed in terms of volume of fluid, as I told you, volume of fluid per second. And for the compressible fluid, the rate of flow will be fluid as like usually the weight of the fluid, flows across the section, weight of the fluid. And here what we have considered, here we have considered the volume of fluid, as I told you already. Yeah, so if this is the concept is there like quantity of fluid, or you can say the rate of flow or discharge. So what is the meaning of this means, if you consider a pipe and let's consider the water is flowing inside a pipe, okay. Let's consider the water is flowing through a pipe. So in this pipe if you see, so there is no extra, there is no extra input or no extra output is going on, only here it is coming and is going out. That means here it is the input part or inlet part, and it is outlet or output here, okay. Now what is the mass of fluid which is coming here, the same mass of fluid also going out. Okay, that we'll discuss in the next parameter in the continuity equation. But here what I'll tell you, the quantity of fluid, that means the amount of fluid which is entering inside the pipe. So you can say that one in terms of volume. So what is the volume of fluid which is going inside this pipe? The same volume of fluid is going to come outside the fluid, correct? Yeah. And so the rate of flow discharge, that means how we can calculate or how we can define this. The Q will be defined in terms of, one thing is volume is there, and one thing will be your area of this pipe. What is the area of this pipe? That is nothing but A. So we can write quantity Q equal to area into your. Here actually we need to see this volume of the quantity of fluid is nothing but volume, but at what velocity the fluid is flowing, that also we need to consider. I'll give you an example for you. Suppose if you see, you can put two different pipes. So this is, let me draw another one. This is one pipe is there, and which is a diameter of some diameter will be 3 meter, okay, or 3 centimeter is there. So and velocity of flow inside this pipe is 5 meter per second. 5 meter per second. And another one pipe you consider here. If you consider another one pipe where diameter is 5 centimeter and velocity also we can consider 5 meter per second. Now see what will be the discharge from this pipe and what will be the discharge from this pipe. Now as per our concept, if you multiply, see area is different but velocity is same. Okay, if velocity is same, area different, then whose area is more, we can get the more quantity in that pipe. So here obviously how much big diameter pipe is there, we can get more flow in this. Okay, because velocity is same, here also velocity same, here also velocity same, but the diameter if you see we are getting more here. So both are important. Okay, so how much based on the diameter and based on the velocity of the flow, we can quantity will be defined, and it units, as you can see, area unit is nothing but meter square, and velocity you can see that is meter per second. So this one we can write meter cube per second. So the unit of this rate of flow discharge is meter cube per second. So this is one small example what I have given. Okay, but if suppose your diameters are different, one more thing, your diameters are different, but velocity here you are getting more and here velocity is less, suppose 1 meter per second or something like that. That means that flow is very small, very low when it is coming out. So there our quantity will be, your rate of flow will be also different. Okay, so this is the rate of flow or discharge for any kind of pipe flow. So next we'll discuss about the continuity equation. So the continuity equation also related to this, that's why I'm describing in the same lecture both the things. So continuity equation. So the continuity equation, actually this is related to the mass of fluid flow. Now what we have discussed, this rate of flow or discharge, this is nothing but, we can also say that volume of fluid, or we can say volume of flow. Okay, so these things we can say the rate of flow, discharge or volume of flow, all will be, can be like, similar things we can consider this one. But while considering the continuity equation, we need to consider the mass of flow. Okay, so that will be, that concept, it came from the principle of conservation of mass. That is the principle of conservation of mass. Okay, so what is this principle of conservation of mass? This is actually, let me again draw one pipe. So as I already told you previously also, so in this pipe your diameter should be same actually, like input time, the inlet diameter and outlet diameter both should be same. And what is the quantity of fluid which is flowing, that also will be same throughout this area. Okay, and next thing, as I told you, the mass of fluid which is flowing inside this pipe, it also will be also same, like what is the mass of fluid is coming inside, the same mass of fluid supposed to be go outside. So the principle of conservation of mass is nothing but the continuity equation. Okay, and for a fluid which is flowing through a pipe, okay, it's all the cross section of the quantity of flow will be per second will be constant. Okay, that means the volume, that mass of fluid which is flowing through that across the cross section will be constant everywhere. Everywhere it will be same actually. So one more example, one more diagram I will draw it for this continuity equation. Okay, let's consider a pipe is like, you know, diverse type is there. Suppose this kind of pipe is there. Okay, so what this continuity equation says, okay, suppose this is section 1 and this is section 2. This is section 2. So these two cross section, if you see here, area is different and here area is different. So this is A2 we can consider and this is A1 we can consider. So at this flow, at this place, here velocity will be V1 and here it is velocity will be V2, and the density of liquid what we need to consider here, this is ρ1 and here ρ2, but density will be actually both will be same because there is no changes in the density, because you know same liquid which is flowing inside this we can consider it is a density is constant. Okay, it is an incompressible fluid. Suppose it's flowing, the density will be not varied. We know that the incompressible fluid density is not going to change. So for this two section, if you see, areas are different and velocity also going to different because we have seen the discharge. Okay, now as per this continuity equation, what it says, now the fluid flow through the pipe, suppose this is the pipe is there, diverse pipe is there, the fluid flow through the pipe, okay, at all the cross section of this quantity, throughout all this cross section of this pipe of the fluid per second is going to be constant. That means here what is the Q value will be there, and here also the same Q we are going to get here. Okay, so that is the motto of this continuity equation. Okay, so this one actually also we can find out. So what you can say, what the mass of fluid is flowing per second. Okay, here the same mass of fluid flow per second is supposed to be come outside. So how we can derive this equation? As I told you, this one we can write, the mass flow rate. Okay, let me first write one thing. We can write the equation mass flow rate or mass per second, mass per second. So these things we can write, the mass equal to, we can write in terms of kg, unit of this mass kg, and second unit is mass per time actually. So second is time in terms of second. So mass per unit time, mass per unit time, that we can write in this term kg per second. Okay, so this kg per second we can write. Okay, one more thing we know, that density, as I told you, density of the fluid is varying here. So density we can write in terms of, we know that mass by volume. Okay, and if you are going to write in terms of mass, then we can write density into volume. What is the volume of this total pipe, and here density into volume. Now just divide this both the sides in terms of time. In terms of time, let's divide in terms of time. Now this volume, what we can write, volume of the object is nothing but we can write length, width, height, or length, width, breadth, anything we can write. Correct. So this we can again just you put it here, rho into volume place we can write, see this width and height we can write, this is area of the object. So what I'll write, area into length. See, all are length only, but one length is in x, one length is y, one length is about z. So we can write this width into breadth or height in terms of area, and length is there divided by time. okay, and this side mass flow mass per unit time is there. Now this one we can write, see, L by time, nothing but this is the L means distance per unit time. So that means that is the velocity of the flow. So this one velocity of the flow. Now we can write this one mass per unit time. This is nothing but mass flow rate. This is nothing but mass flow rate, m dot we can write. And this one you can see rho into area into velocity. So rho a v. Okay, this is the equation for which one? The continuity equation, rho into a into v. Okay, now if you consider this two different cross section area, then what we can write here? For the cross section area 1 we can write the mass flow rate equal to rho 1 a1 v1. Okay, this is the rate of flow. Okay, the rate of flow at the particular section 1, and similarly the rate of flow at the section 2. So as per this definition, this should be equal. What is the rate of flow at the section 1 and what is the rate of flow at the section 2? So that is rho 2 a2 v2. Both should be equal. So for this, if the rho is, as I told you, the rho density is fixed. Okay, and you can write what? A1 v1 equal to a2 v2. Okay, a1 v1 equal to a2 v2 as per the continuity equation, this one. So this is nothing but the derivation of this continuity equation, which is also known as the conservation of mass, the principle of conservation of mass. So I hope you understand like how to derive this continuity equation and what is the rate of flow and what is discharge. Okay, keep in mind that this discharge is nothing but it talks about the volume of flow, and while coming to the continuity equation or conservation of mass is talking about the mass of flow. Okay, the mass of fluid flowing per unit time. Okay, per unit time. So if you are having any kind of query regarding this, you can give a comment on the comment box. Thank you all.